YouTube is full of heat pump reviews and cold weather performance tests, and many of them like to show a very toasty supplier temperature to prove how well the system's running. Now, heat pumps do play by a completely different set of rules, so let's take a look at why supply air temperature can sometimes be very misleading. Now, I geeked out a little bit. I took quite a few temperatures and a lot of electrical data over about a 14-hour run, and what I found was pretty interesting. Let's take a look at the supplier temperature out of the unit, which is what we're focusing on here. And you see all these squiggly up and downs, and all that is the unit cycling on and off whenever the room met set point temperature. The bottom of all these lines, the unit is actually in the off position, and we're just reading room temperature. And at the time, I had the set point set to 72 degrees for the entire run. The peaks on this graph is what we're really interested in because that is the actual temperature the unit was putting out when it was running. And if we trace all these peaks all the way through the entire run, we come to find that the output temperature of the unit didn't really vary by much. We're talking about maybe 84 to about 90 degrees Fahrenheit. Now, that doesn't really tell us much, but here's something that reveals quite a bit. What we're looking at here is the actual power draw of the unit in watts over the entire run. And there's a lot going on here. We see an average of 800 watts part of the run, and it's cycling on and off. We see a nice constant steady run with no cycling at all. Sometimes it's pulling 600 watts. So, I mean, it's doing a lot of different things. Now, that purple line, that's the interesting part because that is the outdoor temperature over the entire run. And we started off at 12 degrees Fahrenheit. We ended at about 36 degrees Fahrenheit. And yet the output temperature of the unit stays within a very tight 6-degree band, no matter what the unit's doing. Now that's not a bug, as I say, it's a feature. I like to call it the comfort veil. Heat pumps are designed to intentionally minimize how much you feel all these changes going on underneath the hood of the system. It's a lot like cruise control. When the car's going uphill, the engine's working really hard, or the car's going downhill and it's backing off, the car keeps going at the same speed. Heat pumps do exactly that with the supplier temperature. Just like cruise control, the output temperature you feel stays steady, even when the system is working harder behind the scenes. And that's why supplier temperature alone doesn't tell you how hard a heat pump is actually working. And it doesn't tell you how efficiently it's running either. Now, there certainly can be moments when the unit's putting out a higher temperature, and this will usually be on a startup when the room is cold and the unit has to put out a lot of heat to get the room up to temperature. You can also see this very briefly after a defrost cycle, and sometimes you may see it when the unit's reaching its maximum capacity and it can't really back off without the room losing temperature. But regardless of when it happens, it should be brief and you don't want to see it a lot. When temperatures stay in that nice moderate little tight band, you know the unit's doing a good job at the most efficient rate it possibly can. I'm working on the next video where we're going to take a look under the hood and see what good performance really looks like with cold climate heat pumps. Hope to see you there. Thank you for watching.